Hello everyone and welcome to today's webinar, Databricks Overview and Delta Lake Deep Dive. Thank you for taking time out and being here today. Databricks is a cloud-based data engineering and data science tool used for processing and transforming massive quantities of data and exploring the data to machine learning models. Databricks is a managed platform for running Apache Spark, and Delta Lake is an open source project that provides asset transaction, scalable metadata handling, and unifies streaming and batch data processing. To talk on Databricks and its features, we have with us today Vishal Vibandik. Vishal is a senior architect and AWS expert who has delivered multiple large-scale data modernization projects for Fortune 500 enterprises. Vishal brings in rich experience in Apache Spark and also has recently won Databricks Partner Champion Award. Vishal today will be giving us an overview on Databricks, talk on Databricks' latest features, provide overview on Lakehouse architecture, and also demo us one of Databricks' key feature called Delta Lake. Without further delay, please welcome our speaker and over to you, Vishal.
Hi, Srivatsan. Thank you for the introduction. Hi, everyone. This is Vishal. I'm a senior architect with Cognizant and been practicing Spark for last 5 to 6 years and recently migrated a couple of applications onto the cloud. Let's get started with our Databricks session and we'll quickly go over the agenda here. So our today's agenda is we'll be going over what is Databricks briefly, what the company is. We'll be talking about some Delta Lake features which were introduced last year and which was a big game changer for Databricks and overall for the big data community. We'll be doing a quick demo on that. We'll talk about Lakehouse architecture briefly and then what are the new features that came up with Data and AI Summit in 2021. So let's moving on to Databricks. So what Databricks is essentially started with the founders and creators of Apache Spark. It was a PhD project which was donated to Apache Foundation. And later on, these creators of the Apache Spark, they went ahead and started a company called Databricks, which is completely cloud native, no on-premise presence. So it's a cloud data platform which is based on the modern Lakehouse architecture now. And it's a unified platform, which means that it is for data engineers, data scientists, and data analysts as well. That's how they were branding their company until last year, which is a unified open platform. And recently, starting this year, they've been branding themselves as a Lakehouse company, not calling them anymore on a Spark company or a unified open platform company. They have the maximum contribution to the open source Spark, and that's the way they can quickly get turnaround on any issues that may come up with Spark or any new features that need to be introduced on the Spark. Again, their maximum contribution to open source Delta Lake, Colas, etc. Essentially, Databricks is a web-based platform for Spark to run Spark code, to do the cluster management, and you can also run notebooks on Databricks. It is built for the cloud. As I said earlier, there is no presence for on-premise. It's available on AWS, Azure, and recently they went GA with Google Cloud as well. So it's built for cloud. Your data gets stored into low-cost cloud object storage, as S3 or ADLS or GCS. And it also provides a good version of collaborative notebooks that you can share with your data engineers or data scientists or even the data analysts. It also has a powerful machine learning framework called MLflow. Again, a great feature that is there in Databricks. And recently, they also introduced a feature called SQL Analytics. So Databricks really lacked a query engine as such to run any ad hoc queries or to run any canned queries, etc. For mainly for the data analyst. They had great processing power using Apache Spark for mainly for massive data processing, but they really lacked into when it comes to the querying and BI part of it. So they launched an engine called SQL Analytics, which you can use to query and create visualizations, dashboards, and it's extremely high performant engine, highly scalable in the backend. Moving on to the next slide, here we have a high level reference architecture which is provided by Databricks. This architecture is on AWS. As we see, it's a standard big data architecture wherein on the left side you have a lot of different types of data sources such as files, you have RDBMS data sources, you may have structured or unstructured data that's coming through streaming, some IoT data or data that might come via the API gateways, etc. Databricks kind of sits in between your data sources and your data consumption. So the main central part, which is of the data ingestion into your lake and processing that data into a usable output for whoever are your users, that's where mainly the Databricks sits. It's natively connects to S3, natively connects to many of the tools on Amazon, like Amazon Kinesis, Glue, Athena, etc. Can read the data from Kinesis, it can read the data from Amazon S3, do all the processing that's needed, that's needed to be done, and finally produce an output which can be consumed via either Athena or Redshift, or you can use QuickSight through Athena on that. It easily integrates with AWS Glue catalog as well, and basically security is provided by native cloud features, as well as Databricks has its own security framework as well. So just a high level overview of the architecture. Similar reference architectures are also available on Azure using Azure Data Factory, Azure Databricks, and Cosmos DB, or a SQL data warehouse on the consumption side. And similar for GCP as well, where you can read the data from GCS, PubSub, etc., process the data and make it available either through Databricks or through BigQuery and so on. Moving on to the next portion of our presentation here, Delta Lake. But before we start with Delta Lake, let me quickly go and start the cluster here. That way, when we are ready to, okay, until the cluster starts, let's go back to a slide here. So Delta Lake, what is Delta Lake? It's a reliable and a performant feature that was introduced in Spark Summit in 2019 by Databricks. Essentially, it's a virtual layer that sits on top of your storage. The storage may be your S3 or ADLS or GCS, whatever is your storage. So it's a virtual platform that sits on top of your storage. It's an open source format that Databricks introduced, but essentially it provides you much more capability, much more improvements over what Performance Spark used to provide on-premise. Essentially, they came up with a couple of Spark SQL commands like optimize, vacuum, and zorder, which provides a great performance improvement. They also made sure that the schema enforcement and schema evolution is provided on data lakes. It also provides a feature for time travel, which means you can go back a few versions of your data, which was definitely not possible when any updates or any deletes happened on your data lake. Another key feature was because of the way Delta Lake is designed, it provides ACID transactions, and you can now easily do updates, deletes, and merge SQL operations directly on your Delta table, which was definitely not at all possible on your Hive-based or Hadoop or HDFS-based systems. This was kind of really a game changer, which has increased the developer's output by many fold. It provides unified batch and streaming, and you can use the Delta tables as a data source and a sink. What we mean by that is on Hadoop-based systems, you can actually either write the data, or when you're reading the data, you cannot write the data and vice versa. But with Delta Lake, you can right now write the data to a Delta table as well as read the data from the Delta table at the same time. You can write the data to a Delta table and use it as a source of streaming for your next phase into your data pipelines. It provides very easy convergence from Delta to Parquet and also vice versa, which is primarily will be used for many of the data modernization projects when you move from on-premise to cloud. With all these features, let's go into our Databricks environment and we'll try and see how these features line up. Before we begin, let's quickly see our Databricks environment. I do have an enterprise edition, which means I pay to Databricks. It's not a standard free version. And I have my own AWS account, which I have connected to this Databricks environment and using it from there. So essentially, when you launch the Databricks, this is how a web-based UI that you get, wherein you have a section for the data science here. You can create your workspaces. Workspaces basically provides your user management, etc. And you can create your notebooks, which you can essentially run on the cluster. The notebooks can be created either in Scala or Python or SQL. This is the small, it shows here. Like currently my notebook is in Scala, but depending on whichever programming language you're comfortable with, you can either use SQL or you can also use Python. And you can run these individual commands here that are being shown here. These are called as commands in the notebook, and you can just individually execute these commands directly from the notebook. You can interact with the file system using the Databricks file system utilities, which are provided by default. You can write any of your Spark code using Scala, or if you want to use Spark SQL, Spark session is already provided to you. So you can start directly writing data, or start reading or writing the data using the notebook. The next feature here is the data, wherein you can go and see what all databases you have the access to. So right now I just have a default schema that I've created, and I have a couple of tables that I have created, but you can go and view the schema from here, and you can basically preview the tables, etc. You can also go ahead and create the tables using this web-based UI. Next section is the compute section, wherein you can go ahead and create your cluster. You can either create a job cluster, or if you want a pool of VMs available, should be available for your consumption, you can create those pools also under this. So let's look at this demo cluster that I had created. And if I go ahead and just click edit on this, we can give whatever name we want. The cluster mode, right now it is running already. It's not letting me edit, but you can have a standard mode or an interactive mode. Standard mode is essentially when you want to run your jobs or when you want to run your notebooks on it, you can use that. Whereas an interactive cluster will mean that multiple users basically can share a particular cluster. You can use a pool of virtual machines. So you can, once you define your pool, so before your cluster actually starts, your underlying cloud provider will launch VMs for you, and all the compute will be basically running on those virtual machines. So if you want your cluster to start like right away, you can create a pool of those VMs, and those VMs will be kept hot for you. That way the cluster startup time is reduced to like hardly any seconds. But even if you do not have a pool created already for you, because they will always be, your cloud provider will always be charging you for that. So if you don't want to have a pool and just want to start your cluster with on-demand instances or spot instances, it hardly takes a couple of minutes for your cluster to come up. So depending on your need, you can go ahead and choose whatever type of cluster that you need. Great thing with Databricks is the runtime versions. Databricks always provides the latest version that is available on open source, and which they already package with their distribution. So you don't really have to wait. Whenever open source Spark releases a new version, that version is essentially immediately available with additional features, which Databricks, of course, will package and provide it to you. That's not true with other Spark providers, maybe EMR or CDP or any other providers. They will have to wait at least for some time to package the open source Spark into the newer version and then provide it to you. But with, at least with Databricks, you get an immediate access to whatever new features that are launched. And here, as you can see, there are like bunch of versions that are available for you which are on older versions of Spark, which are still on a long-term support, as well as to the whatever is the latest version of Spark that is available. Couple of good things that you can do on your cluster is autopilot options. You can enable auto scaling. If you enable, you can provide what is your number of minimum workers, what maximum workers you want. Right now I'm going to disable it because it's just for a demo. I'm just going to use a single worker node here. We can enable auto scaling on your local storage of those VMs as well. And this is also a cool feature which basically terminates the cluster after a few minutes of activity. Essentially, when you migrate from on-premise to cloud, the biggest thing is cloud always charges you. Even though you use the infra or you don't use it, if your VMs are running, your cloud provider is going to charge you for that. Databricks compute will also be charged as long as your cluster is running. So that's something that is really important to note here, and that's why this terminate feature is really cool. That if you do not use this cluster for say 20 minutes, this cluster will be terminated along with underlying VM instances. You can choose different worker types depending on your needs. You can use a compute optimized, storage optimized, which is i3, which is enabled for Delta cache, or you can use some general purpose VMs, a GPU accelerated, depending on whatever use cases you have. It provides support for a vast a variety of what virtual machines that you can select on any cloud platform, like whatever are the native supported VM types, all those you should be able to use on particular cloud. You can also set some advanced options here, which like if you want to go with on-demand instances or spot instances. If you want just doing some experiments, just use spot instances, save some money on that. And you can also select which zone you want to deploy your virtual machines, what spot price you want to play, and basically so on and so forth. Additional Spark related feature configurations can be done directly on the Spark config, which you might be using on your on-premise while you submitting a job using Spark Submit. You might be sending some parameters to Spark. All those can be directly configured here, environment variables, and all of these things can easily be set up on when you create basically a cluster. There are good security features wherein you can limit the cluster usage to a particular group or particular set of users and so on. We'll not go into those details right now, but yeah, security wise, it essentially uses IAM roles from AWS, as well as it provides its own security on top of it. There's something called just jobs here. You can, during your development phase or your production phase, of course, you will need to run your data pipelines, and your data pipelines basically will run multiple sets of jobs. All those jobs can be created here. Either you can use this web-based UI for that, or you can use standard API which are provided by Databricks. You can create the jobs over here. You can create the jobs using Notebook, or you can upload your own jars, or you can provide your own Spark Submit commands or your Python code. A lot of options are already provided here. You can create a new job cluster, or you can submit the job to an existing cluster. A lot of good features are available on how you want to create your jobs and how you also want to schedule your jobs. So scheduling can either be done through this jobs UI itself, or you can have your own external scheduler, like you can use Talent or Apache Airflow or whatever other scheduling tools that you might be using. So one great thing about Databricks is the documentation that is provided by Databricks on their website. If you go to their website, whatever documentation is provided, it's really very useful, and I have not seen that level of documentation from some of the other providers. All the APIs, all the security features, all the setup features, whatever basically that you need to do with Databricks is really very well described on their website. So if you visit their website and go under the knowledge section, you will see really a good ton of information over there. So going back to our notebook here, we'll be quickly going through some of the features which came up with Delta Lake. Um, Let me start running this particular section of the notebook, and then I'll explain what's happening here. So on my S3, let's go back to EC2s. So since I started my cluster with one worker and one driver node, you can see there are two instances which are running here. Essentially, one is my driver, one is my worker node. So whenever you start your cluster on the backend, your cloud provider will be running your VMs, and this is where you will be charged for. Going back to S3 where my data resides. So when I created my Databricks account and I connected with it, I was supposed to link it with a particular bucket, but you can have multiple buckets linked to your Databricks subscription. And essentially, this is where I'm storing all of my data under this folder called as tables. So I have this CSV, data.csv, which I had already uploaded. It is open data. It is some FIFA 2019 data that I'm using for this demo. And I had already uploaded this CSV onto my S3, and using this data, I'm going to basically create all of my other tables and what I'll be using for this demo right now. So essentially what we are doing in this particular step is we are reading the data from this CSV, which is stored here. We're just doing a print schema just to read this data frame. And once we read this data frame, I'm selecting about 10 or 15 columns from this data frame, and I'm writing this data frame into multiple different formats. First format is I'm writing it into Delta format into this table, FIFA data table. Then I'm going to write in the Delta format, but I'm going to partition it by a column called nationality. I'm going to store it into this particular folder. And I'm going to write this again into a Delta format into a different folder just to show the schema evolution. And I'm going to write it also as a standard Parquet format into this particular folder just to show how Parquet and Delta are, they do look different. So essentially Delta is built on top of Parquet. So all the underlying data stays in Parquet files, but Delta uses a lot of metadata on top of it, basically to whatever features that they are providing. So this particular command has run. So after running this particular command, if we go and see in my FIFA data underscore PQ folder, all you will see is basically the standard Parquet files that any Spark job would write. Like in this case, it is writing 3 Parquet files with a success, committed, and started some metadata. So this is all standard stuff that we always see with the Parquet files. Now let's go and see how the same data looks in a Delta table. So I have this Delta table into this FIFA data folder. Let's see this one. So again, here if you see, it also writes the data into same 3 sets of Parquet files, but along with that, it doesn't have a standard Parquet metadata, but it has a folder called underscore delta underscore log. So this is a critical folder which basically Delta uses to store all of its metadata. Again, it's a standard JSON that it keeps on writing. When you do your own notebooks, you can go ahead and view what data it has, but it's essentially it has what is my version of the data and what files are associated with that version of the data. And how it changes, we will see in a few minutes. Other folders into this one are just useful for a little bit later, but let me show you the Delta partition. So similar to your Hive tables are partitioned, again, Delta tables can also be partitioned same way. I partitioned it on the field called nationality. So basically it's going and creating the folders on your storage depending on your partition key. So same features that you used to use with Hive, all those same features are exactly available in Delta with no changes basically, but it is going to give us a lot more benefits. So let's go here. Okay. So I'm just going to go ahead and drop my existing tables, and I'm going to create tables using this data. First is the Parquet table. So as you see in this notebook, we can essentially very easily use Spark SQL because Spark session is already provided to you by this variable called Spark. And you can directly start writing all your Spark SQL statements or whatever Scala code or Python code that you want to write. You can straight away write using these notebooks, and you get the output right here uh, into the same command. And you can also view your Spark jobs from here. You can go and view your Spark UI to see what stages were executed, what's the environment, executors, what kind of a SQL it is running, all the standard stuff that comes with Spark UI, all that is basically visible here. So if you want to debug anything, or you want to say like how your stages are running slow, or what exactly is happening in your Spark execution, you can always go and see it all over here. So essentially a table was created for us using this SQL command, and we can just go ahead and just do a quick count on this table just to see how many records got inserted. So we have about 18,000 records into this Parquet table. You can write all your standard Spark SQL onto this Parquet table, and you can also do exactly the same thing on your Delta table, which will be here. So I'm just going to go ahead and drop my existing Delta tables, and I'm going to create the new Delta tables. As I said earlier, we're going to create a couple of Delta tables just to show different features. So first is my plain Delta table, FIFA data. Second is the partition table, and the third one is for the schema evolution. So our tables are created here. And let's go ahead and run the same query that we run on our Parquet table. And let's go ahead and run it here. So 18,207, that's the same number of records that we have in our Parquet table. So essentially, count wise, data wise, your data is going to be exactly same in your existing Parquet table versus compared to what you will have in your Delta tables. Same thing with your so same queries, basically you can write. We ran this same particular query, select a couple of columns. We ran this query on the FIFA Parquet table, basically reading a couple of columns from here. The exact same query now we can run, and we can compare the output. The output is going to be exactly same because basically it's the same data that's there in the line. So as you see, we get the records back from the table, but it's exactly the same data. So no difference as such. So Delta is not going to change your data in any way. It's going to essentially sit as Parquet files. So if we go back to our S3 and then see how the data looks like, FIFA data, yeah, this is the table that we had, and we had these three Parquet files in Delta. So now a good feature which came up for performance was optimize. So as some of you might know that when Spark writes the data, it writes into multiple small files just to increase the parallelism and to make the maximum use of its executors and core. So it's going to write probably hundreds of files depending on your data size. It's going to write those many files onto your storage. But an issue that comes with this is sometimes you may have stuck production jobs because some files were not written properly, or when you're trying to read the files, some files got corrupted, and so on. As well as if you have a large number of files under a table, then of course the IO will be much slower. So to alleviate these kind of issues, they came up with a command called optimize, wherein all the files which lie under your Delta table, those will be optimized either to say 256 MB or a 1 GB file, depending on whatever size that you provide. And it will just create one big large file for you that will be much more efficient to read and write as well. So if you run this command spark.sql optimize, and I'm giving just my Delta table name here, and we'll see how differently basically it now looks. So essentially the table is going to remain same. If we go ahead and again query on the table, we can query the table again here. The data remains same. There is no change in the data, but what change in the backend is over here. If we go back to our S3, if we refresh this, so here essentially what you're going to see now is you had three files earlier. One is this Parquet, this Parquet, this Parquet. So along with these three Parquet files, now you have a fourth Parquet file here, which is 636.9 KB, which is a combined file that was made out of these three Parquet files. This is what was done using optimize. And if you see the Delta log has written another JSON here. This was my original JSON, and this is my 01.json. So essentially, Delta has written the data into a newer version. The best feature with Delta is it never overwrites any files. you might be knowing that on your on-premise HDFS-based systems, whenever you want to do any updates or deletes, or whenever any new data comes, you sometimes go ahead and override the existing set of files, and that is what causes inconsistency in the data. So Delta completely eliminates that. Delta always writes new files. It's not going to touch your existing files in any way. It's going to leave those files as is, but it's going to add a new optimized version of the file. And the Delta log will now point to this as your most current version of the file. So if we go back to our notebook here, and if I issue this command called describe history, let's see what history it has. So since I did two operations on this table, one was my original operation and the second one was optimize operation. So here, if you see, my version number 0 is essentially the first write command that I did. And my version number 1, which I did just now, was the optimize. If you see here, this is the optimize that I performed, and it shows my user ID, timestamp, and everything else that is associated with this. So essentially, the Delta table is going to maintain the versions of your data. Since it's not overwriting your files, it always has a pointer to your old files as well as your most current files. It's going to show you a history of both. And this essentially enables a feature called time travel, wherein now if you want to read the data from this version, you can go back and provide this version in your where clause. It will read this version of the data. If you want to read this version, this is the most current, which will always be available to you. But if you want to go back and read the data from any of the older versions, you can go back and do that now with Delta. You can also do the optimize by certain fields. Say you know that your analyst or basically your pipelines are going to use the data most frequently by a couple of columns. Say in this case, two columns like nationality and club. If I know that I'm going to mostly be reading the data on these two columns, or maybe another 5 columns, then I can do the optimize using only those columns as well. That will, again, when I try to read the data using these columns, the data read will be much faster, because the way the Parquet files will be organized will be optimized for these particular set of columns. Again, it's a simple Spark SQL command that you can run. So maybe let's try and run this again and see how our data changes basically. So yeah, optimize has been done. And if I go back and refresh my data here, uh, so since there was not really much of a change because my data set is really small, it didn't basically write it into a new Parquet file. But maybe if I had a much larger data, and maybe if I'm giving a different set of columns, it would probably go and optimize the data and then write it into different set of Parquet files. So even after Z order, if I run the queries, you get the same set of results. The queries will definitely run much faster. Right now, I'm just running with a one worker node with a very small set of data, so we can't really see the performance here. But the idea is that if you know some of your fields in your data are frequently queried upon, you can always do a Z order optimize on those columns. Let's go ahead and see a new feature again, which came up on your Hadoop-based system. You directly cannot issue update statements because those Spark SQL statements are definitely not supported on our on-premise based systems, which do not use Delta Lake. So let's do a quick select name, nationality, wage from this Delta table. And let's try and first update our Parquet table and let's see what happens. Let's run this. Okay, as expected, we got this error. Update destination only supports Delta sources. That means Parquet tables cannot be directly updated using Spark SQL. We do use a lot of other ways to update our tables, where we partition our tables, we redo SQL outer joins, and then we do insert overrides on those partitions. So as a developer, we do a lot of these kind of things to update the data, to delete the data, and you know things like that we always do, which basically takes a lot of time from the developer, as well as if you see your code, it looks really clumsy, and something that can be done with a simple update statement, you have to write a bunch of lines of code to do all that. But with Delta, that is completely changed. You can straight away fire an update and update the data. So let's fire this update statement on our Delta table. So what we are doing is we're setting the wage to euro 100K, where nationality in Argentina and Belgium. Let's comment out this one. Okay, you can have it on. Let's run this. So as if you see here now, the Spark jobs are already running, and it is going to go ahead and update the data onto both of these tables for me. So update has been complete, and now if you see the data for Belgium, let's see what is the wage here for Belgium. So as expected, the wage column has been set to euro 100K, where the nationality was Belgium. So simple update statements which was not available, now it's available. So this is a great feature even for your data analysts. If they want to really go ahead and change some data for their analysis purpose, then they in the old world, they always have to come back to the data engineers, tell them that this is what I want to get updated. An engineer will write some code and then push it into the environment, then update the data, and basically it takes a lot of time. But with these new features, you can directly go ahead and update your data, delete your data, or merge your data with your incremental data that is coming in your data pipelines. So really cool features which came: update feature, delete feature, and merge feature with Delta Lake. Let's delete some of the data from our Delta table. Let's do this one. We can, where nationality is France, and then we're going to delete from this table where nationality is France. So comment this first. Let's see that we have some data for this. Yeah, we have some records here, and then now let's go ahead and delete this data where nationality is France. So run this command. Okay, so my Spark job is done, and then let's go back and run this Spark SQL again. Okay, I don't get any data because I deleted the data for this particular partition from my Delta table. And if we go back and see the history of this table, like what all again happened onto this table, let's go back and see this history. Okay, now if you see the history, initially we had these two versions, 0 and 1, which was initial write version and an optimized version. After that, we did this version number 2, we updated some data. So it's showing that as an update here. And we did a version number 3, which essentially is deleting the data from this table. So essentially this Delta table is holding all the versions of the data that you had, which basically enables it for time travel. If we go back and see our S3 now, okay, we have a bunch of files available here. Let's sort it by the time. And so this is my original version, which I had at 950. I had 3 Parquet files, which then I optimized at this particular time. Then I did an update on this Parquet file at this time. And then I did a delete on this Parquet file at this particular time. So essentially it's maintaining all your previous data that was originally present along with your latest data. And if you see the Delta log folder, we'll see a version number 3, version number 2, and version number 1 and a 0. All those versions are internally maintained by Delta. Okay, now what is really the use of maintaining this data? So if I want to query the data version as of 1, that is when we did the optimize, if I click show, I see the data where the wage is still the original wage, where the country was Belgium. We updated this to 100K in our update statement, but in the version number 1, the data is still 355K. So if it so happens that you end up in deleting the data or updating the data which you did not really want to, or if something goes wrong into your production, your code doesn't behave as it should, and if you end up in deleting or updating any data, what do you do on premise? You can't do anything. Once your files are overwritten, they're overwritten, your data is gone. But with Delta, if you feel that in your production systems as well, that you shouldn't have deleted some data or updated some data, then you can always go back to a particular version. Just read this data into a data frame where version is as of 1 and insert overwrite your tables. Simple as that. Really a cool feature which came with this Delta Lake. Okay, and we already saw the all the history, etc. But what's really the use of having these many versions, and how many versions should we really keep in the Delta table? So it totally depends on your use case. Ideally, you can keep the data, let's say for last 7 days or last 30 days. But there is no such limitation as such from Delta that how many versions you should keep, because it's going to ultimately cost some money on your storage, not a lot, but still it's going to cost you money. So to delete the versions which you do not need, there's a command which came, which is called as vacuum. So let's see, where do we have vacuum here? Yeah. So here is the command which we got, vacuum. Um, by default, the vacuum can be done only for last 7 days. Like the data that was existing before 7 days will be essentially vacuumed out of your storage. But we can override this retention duration check by setting it to false, which means I can set whatever is my duration, and I'm going to vacuum the data from this table, FIFA delta. So let's see if I run this particular command. Since I'm just giving it 0.1 hours, let's see if it still deletes any data. Okay, so it says found files and directories that are safe to delete. And this was just a dry run, just to see that how many files are really eligible. I did not actually perform vacuum. We'll be performing that vacuum now here. So let's go and perform this vacuum. Okay, so it now says deleted 5 files and directories in total of 1 directories. Let's go back to our S3. We had 7 objects. Let's see how many do we have now. We have only 2 objects. So essentially, we have only the most recent version of our data, which was basically the version number 3. So going back to our notebook, if I go ahead and try to select the history from this delta table, it's still going to show me what was the history. But if I now try to query the version 0 or version 1, it's not going to show me that data. So let's do that here. Version as of 1. Let's do a count. So count, it's still going to show you, but let's see if it's actually deleted the data or not, because sometimes it takes time for it to really delete the data. But yeah, it's not showing any data for us. Version 1. They're still showing the data, but maybe if we go back and check this thing after some time until all the files are completely deleted from our backend, there'll be no data that will be available for version 0 and version 1 into our system. So essentially, to save the cost on the storage and to make sure that we do not store unwanted versions of our data, we can basically clean out all of those using this simple command called as vacuum. But use it obviously carefully. You never want to delete your data which is like, say, most recent or which you still want to keep for last few days. So ideally use a 7-day or a 30-day retention kind of for this. Another cool feature is basically how do you quickly do the conversion. So let's use this table, which was our Parquet table earlier. We don't have anything in this table. Okay, let's write it for conversion for Parquet. Let's run this one. It's going to create another table for us, which is going to be a Parquet table at this location. And then we're going to now go ahead and convert this into a Delta table. So we have 18,207 count in this table. Now we are going to convert this table into a Delta table. So FIFA Parquet for conversion. Let's see. So we have the table over here, which is standard Parquet, 3 Parquet files with its metadata. Let's go ahead and convert this into a Delta table. So this scenario arises mostly when you're trying to do the migrations from on-premise to cloud, where you can copy your existing Parquet data, run this simple command on your Parquet data, and your table is now a Delta table. Let's refresh. So it has written a Delta log for you. That means it has already converted this table into a Delta table. And now you can go ahead and do all these updates, deletes, and whatnot onto this particular data set. So essentially, you can convert from Parquet to Delta, Delta to Parquet. Delta to Parquet you might need if you want to port this data to any other provider after this. Let's say you want to bring the data back to on-premise. Delta may not work there, but then how do you bring your data there? You can just convert it simply using one Spark SQL command, Delta to Parquet, and you can bring that data back to your on-premise and start using it. That's the power of having an open standard on which this Delta Lake is really built on. Okay, we have seen the history, we have seen the versions, etc. And then next part is basically a demo just to show like you can read and write the data from the same table at the same time. Let's see if you're really able to get this thing going. So I'm just reading the data from this particular table as a stream. I'm going to read some data and I'm going to start this stream here. Let's see, the stream has started, and then I'm doing a show on this particular stream of the data. Okay. Okay, stream is about to come up. So I'm writing some data into this stream that we just now started and just doing a select on this age and doing a group by age here. We got some data for age 31, we have these many records, 34, we have these many records, and so on. And my stream is still running. And let's see if we write this. So essentially, you can, when the stream is running, that means I'm enabling this table as a stream. I can do an update, which I just now did here. I appended some data into this table. And when I ran a Spark SQL, I can able to show the data or use this data essentially from this table on, which is basically running as a stream over here. So I can basically write the data into this same table, and I can also read the data from this same table, which is again essentially the power of Delta, which came up with the fact that we are not overwriting files, we are going to create newer versions of the files from that. So this essentially provided the ACID capabilities which were really lacking in your Hadoop-based systems, wherein you really cannot, while you're writing the data, you can't read the data from particular table because your data is going to, the files are essentially going to get overwritten. So really cool feature which came, which is really a very big game changer for the big data community overall. Let's go ahead and stop this query here. And another feature is schema evolution. So as of today, if you write the data into Parquet files into say different schemas into a simple into a same folder, you are able to write it because essentially while writing there is no schema check as such. But when you try to read the data from an external table on that particular data set, your reads will not work. Your table will not get created because it detects different schemas. So essentially, to stop this kind of a behavior where you really want to provide a strict enforcement, Delta came up with schema enforcement, wherein let's see, let's just write this as it gives me an error, a schema mismatch detected when writing to the Delta table. So essentially, I had a particular schema under this particular folder, and I'm trying to do something as temp here, and I'm trying to write that new data basically with this new column added. I'm trying to write it to a Delta table. So it gave me an error, schema mismatch detected. Basically now it is preventing an accidental overwrite of your schema or accidentally having different schemas into a particular folder. But with the given current scenarios where we have data coming from different sources, sometimes data is unstructured, and you really want to have that schema evolution feature, which is right now not possible. If you are using Parquet, you cannot really do the schema evolution on it. You can do it in Avro, but not in Parquet. But if I want to really do it, so let's go ahead and run this one. So only change I did in this one is I set this option called merge schema to true. I did not have that attribute specified in my previous command, but now I have this merge schema to true, and I'm writing the data to the same delta table. The job got succeeded because now the schemas will get merged and we'll see some new columns into this table. So we had added some column into this particular table, and now we are able to query onto that new, essentially the new schema that is evolved from my original schema, having whatever new fields that we really wanted to add. So we added this country ID column, which was basically, we took it as some random number. And if you see this country ID and also a user ID, we added these two fields. Now we are able to see these two fields in our new delta table. The values for these two columns are essentially going to be null for the existing data, but whatever data that might come in as new, for all those new data, it will have correct values. So essentially, we can do schema enforcement as well as we can do a great way of schema evolution on the delta tables. For all of our streaming use cases where we get the unstructured data, maybe from social media, from other data sources, where you want to modify your schemas on the fly, you can do it now. Whereas compared it to with your HDFS or Hive world, you really can't do that. You have to drop the external tables, you have to read the schema, convert the schema, write the data again, recreate your tables. But all that has been now eliminated, making our lives much easier for everybody, for data engineers, for your analysts, for even for your data scientists, where you want to really produce, new columns or new metrics on your data and then start using them right away. We already saw the optimize, we already saw the history. So as far as our demo goes, that's all I had from the demo, and we can go back to our slides quickly. We covered performance, we did schema enforcements, time travel, ACID transactions, unified batch and streaming, and easy conversion. So all of these great features we are now easily able to use out of the box with Databricks. Delta Lake project is also made an open source by Databricks. So if you really want to make use of it, maybe go ahead and read its documentation, and you can start using it if you really want to use it outside Databricks as well. Next, we'll quickly touch upon another important concept that is being going on, which is called as Lakehouse. Databricks is now branding itself as a Lakehouse company. It doesn't brand itself as a Spark company or a unified platform, but it's a Lakehouse company. So, what essentially is a Lakehouse? Lakehouse is not a product. Lakehouse is a concept. It's just a way of how you visualize your data. It's a new data management paradigm which will integrate the benefits and flexibility of your old world data warehouses. It will integrate that very easily with elasticity, resilience that is offered by the modern data lakes on the clouds. So essentially, Lakehouse is just a concept. So we had data warehouses a couple of decades ago. Data warehouses had really great features, but it was providing support only for structured data, used to create data mats, used to run your BI and reports on top of it. But they are more of a commercial products. Upgrades are a little difficult. You get stuck to a particular vendor, and then you cannot really do unstructured data. You can do streaming on it. Elasticity is very limited. You can't really do much with all of that. But all of those features were introduced into data lakes. Data lakes now on the cloud now are highly scalable, elastic. You can increase your capacity at any point of time. It provides support for structured data, unstructured data, provides support for streaming, data science, and all of that good features which data lake provides. But still, the BI capabilities and the reporting capabilities were still limited on the data lake because there were not really great integrations of all of these BI tools or reporting tools. And how do you really expose the data from your data lake? Even if you see Databricks until few years, or maybe like until last year or before that, the data querying capabilities were still limited until SQL Analytics was introduced, wherein if you really want to query the data in Databricks, you need an interactive cluster, which means it is a little bit expensive cluster, as well as you have to always have that cluster running so that you can query onto your data in Databricks. But with SQL Analytics and with the Lakehouse paradigm, now that all is changing much more. So essentially, Lakehouse says should provide transaction support, which came with Delta Lake. It should provide schema enforcement evolution, which basically is required for a large number of use cases. So with Delta Lake, it provides great BI support wherein you can connect your BI tools, Tableau, Power BI, Alteryx, whatever tools you might be using. You can connect all of them to Databricks as well as to SQL Analytics. So good BI support. Storage should be decoupled from compute, which is what is there on the native clouds. Storage is separate, cloud is compute is separate. Openness, the format should be open so that the contribution can be extended to a great extent to anybody who wants to use this particular paradigm. It should support diverse data types, structured data, unstructured data, semi-structured data, and so on. It should support diverse workloads such as data engineering, ad hoc querying, data science, machine learning, and so on. And it should also support end-to-end streaming, which is becoming a very critical use case nowadays. So essentially, Databricks is one of the companies which is way ahead in the Lakehouse paradigm. But there are other companies also, like Azure also provides with Azure Synapse Analytics and Azure Databricks. It does provide, and BigQuery, Redshift, and Cloudera CDP. They are also providing some of the features of the Lakehouse, but as far as Databricks goes, they are a little ahead in this particular game. So this diagram essentially shows us what we were just now speaking. We had great data warehouses in the past, which evolved into data lakes. But even the data lakes also had limited capabilities of reporting BI and having a unified platform as such for all the use cases, wherein you would still create some data mats for reporting and BI. But with the lakehouse concept, you just put your data into the data lake, which is powered by an open source Delta Lake project, and you can do BI on it. You can do streaming analytics, data science, machine learning. All of that is supported on one single platform. Again, it is evolving. It's not that it is fully baked into it, but it's going to definitely improve from here on. Moving on to the last section of our session here. A data and AI summit happened a few weeks back, and they again introduced some of the cool features and made those features mostly open. First is the Unity catalog, which is basically Databricks really lacked into how do you do the data cataloging, how do you do role-based access and security, how do you do really lineage, or how do you tag your tables, etc., and how do you do auditing if your data stewards or if anybody wants to do an auditing on your schemas, your tables and data, how do you really do it? So a new product called Unity Catalog has been introduced in this summit. It just announced, so we'll really see how this evolves and how best we can make use of it. Next one is the Delta Share, which is basically an open protocol for secure data sharing. So many of you might have already observed that if you want to really share the data with any third parties, or if you want to share the data even within your companies, and if you are using a tool, a different tool, say you're sending your data to your supplier or a different vendor, usually you would take data extract, you would share those extracts over FTP or through S3 or whatever way. And then the team on the other side will kind of ingest that data and make it ready for their analysts to use this data using their BI tools. But all of this cycle is now completely eliminated with Delta Share, wherein you can put a Delta sharing server on top of your Delta data, and whoever are the consumers of the data, they can use the Delta Share client and they can directly access this data as long as they're authenticated and authorized. So a large number of tools such as Tableau, Koalas, and Spark is now supporting this Delta Share feature, wherein you may be belonging to one organization and you want to share the data to somebody in another organization, you can directly share the data. Again, really a cool feature that is going to speed up your overall data sharing capability. Delta Live Tables, again, data engineering made easy. You can build and manage your data pipelines instead of building your silos. Basically, you may be ingesting the data as your raw data. You may be curating that data, transforming it into a different format of the data, and eventually you'll have your golden copy of the data which is used by your users. So you do all this work in silos, but instead of doing this work in the silos, if I have built a pipeline using the delta live tables, as and if I want to really schedule that as and when my raw data comes, perform the raw data ingestion, perform the transformation, curate it, and also create my golden copy. So all that can be done now easily with the delta live tables instead of doing that in the silos. Databricks ML, a collaborative machine learning platform. You can prepare, process, collaborate, and you can do all your experimentation and also go into production directly from this single platform now, which is also a great feature that came for the ML and the data science community into this into the summit. So we are at the end of our session here. I've covered, yeah,
No, go ahead, Vishal.
yeah. I've covered most of the stuff that I wanted to.
Yeah. So Vishal, first of all, it was really an amazing session. It's like in the last 1 hour, we got the last 2 years, what has happened in Databricks, a short summary and a detailed information, right? It is, see, when I started in big data, one of the biggest challenges, how do I keep track of changes, right?
Yeah,
That is a transaction restatement, how I can go and update. And we used to follow that three-step strategy, create temporary tables, then replace the I
yep,
tables and
yep,
all. And that was one of the tedious process that delayed or derailed lot of data lake initiatives, right? Bringing the data warehouse favor in the data lake. And this new feature is really amazing. And way you explained it, it was like pretty understandable. We got all the features, and I'm getting like very excellent feedback of the session. You can see here, right? You can see in the window. This is from Prashant. That's an excellent session. This is from Hatif. Again, a great session. And I'm just a coordinator here. It's all you, Vishal. Right?
sure. Thank you.
There are a lot of good feedback coming in, and thank you for that. Thank you for having producing such a detailed content on all the features, and also being updated with the latest Spark Summit that was there, or rather AI Summit. I'm still used to the old name,
Old
uh,
name, yeah,
Databricks AI Summit that was there
yeah,
recently. Right. Let's go into the Q&A. And again,
sure.
thank you for that. I can see like a lot of other comments coming in on the session as well. Right. So let's start with, there are a couple of questions. Was the same question from Jao and Garrido and Prashant Rati. The most question is, you answered some part of it.
Hmm.
Like when the data set is huge and you create like an delta version of it, and it creates like new version of the storage, will it
Sure.
incur like, is it going to be like double the storage cost, or does it optimize the storage cost? How does it work actually?
So the storage cost, as I said earlier, like since Delta is going to maintain two versions of your data, say you brought in your data, you had a 1 GB of data, it was divided into 100 files, and you got an update, and only some of that data got updated. But then Delta is going to overwrite, like basically create new files for you, and it is definitely going to incur a little bit of cost on your storage because you are going to keep that version as long as you need it, your previous version. But storage costs are really really cheap nowadays, and if you really do an intelligent tiering, let's say on AWS, you can easily move your data from your standard tiers into your infrequent use, or you can move it to into other like very cheap storage. So storage is becoming very very cheap nowadays. So even if you have data into multiple versions, the storage cost will not go up that much, but yeah, it is definitely going to go up. But you can control it by using vacuum if you don't really need your updates or your older data more than say 7 days, or even you can put it for a 24-hour limit that you don't want to see yesterday's updates, you want only today's updates. Go ahead and vacuum it. So it's up to your code, how you write your code and how do you really vacuum out the data. So if cost is really becoming an issue, yeah, you should ideally vacuum it out. But yeah, I mean, there's no harm in keeping, since the storage is so cheap nowadays.
Got it. Got it. And the next question is from Hatif. Hatif is asking, like, can I create a table directly over S3 files without mounting it in Databricks using Spark SQL?
You can do it, but then that's what you will be using the native AWS features. You can use Athena, you can use Glue, you can directly create the tables on your Parquet. But if you use Glue, it will not understand the Delta format. So if your underlying data is into Delta format, Glue will not understand. But what you can do is Databricks also provided a very good compatibility between Delta tables, and if you want to really read the data using Athena, or even if you want to use it using Redshift Spectrum, what you can do is you can create a manifest file out of it. So Databricks provides those API that if you write your data using Delta table, but you want to read it in Athena or Redshift Spectrum, you can create something called as manifest files on top of it, and those manifest files are used by Athena and Redshift Spectrum, and you can directly read that data using both of these technologies. Or same thing with BigQuery. If you just want to write your data and create an external table in BigQuery on GCP, you can still do that. Yeah.
Got it. Got it. There's a question on the cost, but I will kind of rephrase this question a little. One is like, see, there's a cost calculator in AWS, and in Databricks, they charge
Mm-hmm.
by DBUs. So typically, when you see, right, I want it to be up for 24/7.
Mm-hmm.
I know a lot of bad jobs are pretty resource intensive, and sometimes the cluster is running idle. What do you suggest? What kind of architecture have you seen? When people use Databricks, do they just run 24/7? Or they kind of have more kind of an bring up the cluster, they run all the jobs and then come out of it?
Hmm.
What kind of architecture
Let me
you see?
quickly share my screen one more time, and I'll show you how the compute is happening here. Just a quick.
Yeah,
So if we saw our cluster here, right, we had our compute here, and this was our cluster. So this cluster right now is using one worker, one driver, but it is showing you, it will show you how many DBUs it's going to use. Going down maybe. So if when I select this thing, let's go and edit. Yeah, here it is showing DBU per hour is 2. Databricks charges you in DBUs, which is the Databricks usage units. So it's this particular kind of cluster is going to cost you 2 DBUs per hour. And how that translates into dollars or INR is all given on the Databricks website. If you use Databricks website, and if you go to their billing section, you can clearly see how they are going to bill you for that. So pricing, if you go to this pricing website, you can easily compute that if you run your cluster on say AWS for 2 DBUs, if it's a standard cluster, 1 DBU is 0.07, premium, enterprise, all the costs are basically given here. You can convert dollars to INR from here. I don't think they have any different structure for using it in INR, but the prices are all given in dollars. So essentially, calculate your DBUs from your this cluster. Definitely not recommended to use your cluster 24/7 unless and until you really need to use it. Always use terminate after inactivity. That way, at least you will save some dollars on that.
right.
And as far as you go, your native cloud, your cloud is also going to charge you for your storage as well as for your VM. So if you don't terminate your cluster, your VMs are going to run. Your VMs will always be charged. So be always careful when you use these kind of cloud systems where cloud provider also charges you. And same true for Azure, GCP, everybody.
Got it.
But
Got
yeah,
it.
definitely not recommended to use 24/7. You will spend a lot of money.
Yeah, unless there's a streaming job that requires that receives continuous
Right,
data, you want to run 24/7. Yes,
right.
but typically the bad job, it's better to terminate after your heavy workload
You're
is
done
done.
with. Yeah.
Mm. So, and spot instances are there to reduce your cost. That is the other aspect of it.
Absolutely, yeah. Try
Mm.
to use Spot as much.
Mm. So this rather like a request from Gulab, right? Is asking like SQL Analytics is not done community edition. Can you quickly show how to integrate SQL Analytics like license version of Databricks for the first time? Is it something like you can show, or we can maybe do it later as well?
No,
And
in even in my edition, SQL Analytics is not enabled. It
okay,
was into private preview. I think it just very recently went into general availability. So it was still made available to only those who wanted to try the private preview.
got
So I think recently in the Spark Summit, I think they made it GA, but not really very sure. I mean, I really cannot. I don't have any video or anything to show you right now. Even in my edition, it's not enabled.
got it,
But
got it,
essentially, you can. The idea is it's basically another cluster which is highly performant compared to your existing Databricks cluster itself. The query performance is many times faster than what it used to be on the cluster. It is highly available. It will auto scale and auto terminate and all the good features that came up with it.
Got it.
And it's rewritten into a technology called Photon. It's written in C language now, and much faster than what it used to be.
Got it. Thank you for that, Vishal. Thank you for giving us the background overview of SQL Analytics because it's completely new. It's good to know that.
Yep.
So the next question is from Prashant. Prashant question is in respect of data pipeline, which layer should be version? Raw, intermediate, input data to model. What do you think in your experience?
Usually we do the versioning on the intermediate data. As far as raw layer is concerned, I mean, it's up to your framework that uh, we don't really want to update the raw data because you always want to have the history of what data basically came from your source systems, right? Even if you want to go back and reprocess the data, we usually want to do just appends in the raw layer. We don't want to do any upserts on the raw layer because otherwise you'll basically lose the history. But when the data comes to your next layer where you curate the data or when you do your apply your CDC logic on top of it, that's where basically you'll be doing upserts, inserts, or deletes wherever required. So that is where I would say you can enable the versioning on the data. And yeah, make sure that you keep the versions as long as only you need it. Don't keep it like for forever, basically.
Got it. This is a follow-up question from Prashant again. See, you showed about the multiple version. Delta is
Mhm.
stored in its as a separate copy, right? Can we see the difference between two runs in the Delta?
As far as the data is concerned, there is no difference. But I mean, I can show you the how the data looks like, the way the Parquet files are organized, if that's what is.
More like I think like Prashant question is like, okay, I made a modification in the data, right? And it's
Mhm.
creating a new file. Can I go and check what was the incremental changes, like kind of what a version control does for code, right? Is that a way can I just diff the data between both?
Um, I have deleted older versions of the Parquet now into this one. So um, let me really still see if it's available on one of the
Otherwise,
table.
it would be just like, is it possible that that's mostly on that rather than seeing it?
Let's see workspace. Let's see. Cluster is also terminated. No, I don't have it right now to show the difference. But the idea is since the files are basically created newly for you, you can go back and read the data from your previous version. So
Got it.
version as of yeah. So essentially, when you do the updates, you can go and read your older data with this version as of one, version as of zero, and this is how the versions will look like. When you run this command, describe history, it will show you the versions that were there. This was our first write, optimize version, update version, delete version. So if you pick up this version ID, or even if you pick up the timestamp, right, that gives show me the data as of this particular timestamp. You can put in the version, you can put timestamp as of whatever was the timestamp. So if you try and query the data, simple Spark SQL statement again, it will read the data into a data frame for you. And then you can do whatever you want to do with that data. And even if you want to do a difference, you can still do. You can get this data into one data frame, older version, get the new data into a new data frame, do a join and see what basically changed between those two data sets. You can always do that. So essentially, everything is stored in the table. You can always read it as a data frame. And if you have it in a data frame, yeah, you can do whatever you want to do with that data then.
Got it. Makes sense. Yeah. Uh, there's a question from Gulab again. Maybe I will pass on to the second part of the question. Can we integrate Delta Lake with on-premise data storage too? And since you're talking about open source, how easy it is to bring Delta Lake into on-premise?
You can use it. There is a project called delta.io, which you will find on GitHub. You can get those libraries, those jars from delta.io. You can integrate with your on-premise also, but not all of the features are really made available. For example, the Spark SQL features, right? Optimize, vacuum, and deletes, etc. Those are, I think, still not available in that open source version of Delta Lake because they made Delta Lake as a concept. They made it open that you can put it on your storage, but definitely not each and every feature is made available. Otherwise, Databricks, it's kind of still proprietary, I would say, but I haven't tried very recently. If you want, you can try that project delta.io and see if those features are all working now. At least a year ago, they were not when I was trying it to use it on our on premise. Didn't really work, but maybe if you want, you can try it now if they have
Got it.
released all the features.
Got it. So this is an interesting question, and maybe I can get started, and you can add on to it as well, Vishal. Right? See, mostly people are confused with data versioning versus feature store. Would love to have something that can clear the difference between two. Like, see what I have seen. Like, if you say see the features, right? The features keep on changing on a daily basis because when you use in a machine learning model, you have some historical features that you compute on a customer or a time-based feature, and you always try to refresh the features. And feature store is basically a concept where you want to replicate the features between your model training and model deployment. Basically, what you do is you move your model training data into a low latency store where it can be used, and data versioning is part of it. So, give a typical example, right? Today, I'm running a machine learning model. I produce some scores, but next day I'm running again against the new data. I produce some scores, and you suddenly see the scores are drifting. It can be an issue with your model itself, or it can be issue with the data. How do you track it back? So that's why the data versioning comes into play. On a daily basis, you run against the version of data and go and track back on what made the model to drift or the data to drift, right? So both go hand in hand. But to be clear, feature store is more like enabling your data scientist with the consistent features between your model training and model deployment environment. Data versioning is common for even non-machine learning jobs where you want historical data or where you want to go and see the data lineage overall. Uh, like anything you want to add, Vishal, on this
No, I
aspect?
think you summarized it well.
Okay. Um, so there's another question. Does open source version of Delta Lake support Delta shared data live tables features outside Databricks?
Yeah, it's very very new. It was just announced few weeks back, so yet to really see. I mean, even I haven't seen really a working version of Delta Share or Delta Live tables. So probably we'll have to wait and at least few more months to see how it really evolves. Because it's just an announcement, and they just showed a few notebooks how you use it. But yeah, at this point of time, we really can't comment. But it should work because what they said is Delta Share is going to be open source. That way, anybody who wants to access the data, any BI tool or any processing tool, they should be able to use it. And Delta Live will be part of the Spark itself. So once it's made available, it should be for everybody,
Got it. And
but not outside
again,
Databricks. Yeah, Delta Live will not work outside Databricks. Delta Share will work. Yeah,
got it, got it. And again, like there are some good feedback coming in for you, Vishal. Like it was a good
sure.
session.
Thank you.
It was a very informative session. Um, what is okay? There's a question rather from your experience, right? Did you get chance to face challenges in real time Delta Lake implementation in streaming? Any idea on that?
Um, Not really challenges. In fact, the challenges were on non Databricks, non Delta Lake based, wherein again, see, if you are streaming the data into a raw layer table, and we had streaming use cases on premise Hadoop based system, wherein we are streaming the data, but then I really want to take the data into a second table because I want to do some cleaning up, I want to do some transformation and make it available for use for business. So as long as your streaming job is running, I am really not able to run another job to actually read the data from this raw layer table where streams are coming in. I cannot read it and transform it. So what I have to do, I have to stop the streaming. Then I have to start reading the data as second job from this raw layer table, transform the output, and then basically make it use for available for business, and then kind of restart my streaming job. But with Delta Lake, this got completely actually eliminated. I can write the data to a table, and at the same time, I can read the data from that same table. So if I'm streaming into a raw table, I can have my next set of pipeline jobs directly read from this raw layer table and actually use it for whatever business it needs to be. So in fact, it made life much easier. So no challenges as such. I mean, it works straight out of the box as long as you configure your streaming etc properly. I didn't really see a challenge in using that. In fact, made a life much easier.
Got it, got it. And again, like Pradeep is telling Databricks is excellent platform for ML and DE, and I agree with that as well, right? The way Databricks has evolved and bringing that cloud neutrality, right? You can run on any cloud, the same version. You can easily migrate from one cloud to another, and it's the same Spark environment or same Python environment that it provides.
Exactly. Yeah. Yeah. It's
Mm,
a
mm,
completely collaborative environment for
that's
everybody. That's what has
right.
made them really stand out. Yeah.
Right. And that integration to cloud tools, like if you're an Azure, you can connect to any of the Azure services. If you're an
Yep.
AWS, GCP, they are completely new. There are some challenges in GCP that they are working on, but once they are there, you can easily connect your data to BigQuery, use the BigQuery push down optimization capability, and bringing into Spark and run your machine learning job. It's pretty has been pretty much de facto for running Spark on cloud today. This is one question. How to manage access of data lake from Databricks to different users?
Edge access of data lake.
I think it comes with the IAM, like you can integrate with the
Yeah.
IAM roles of good.
Yeah. So essentially, the idea is data lake is basically will be in case of AWS, it will be your S3 storage, right? And then your tables are created on top of it. So, and to access the data, you need a cluster always on, right? If you want to read any data, so essentially, if your cluster is on and if you are giving an access to a user to that particular cluster using IAM policies, then that user should be able to read the data from those particular tables. But with this new Summit features, which that Unity catalog, where they have more role-based access policies that will come into picture, things will be a little bit different. As well as you can use some third-party tools like Privacera or Immuta, which essentially provides the role-based access control, column-based, table-based access control, which natively integrates with Databricks. But essentially, the idea is you need your IAM policies, or if you're using your Azure AD, then you can directly integrate with Azure AD as well. So whatever roles that you have in your AD, those get carried over to Databricks, and then you can use those roles to basically control the access to the data. But if anybody has direct access to your storage, like your raw access to your S3 or ADLS, they can probably directly download the files and see it. But we always want to lock that down. That way, nobody has access to your storage.
Got it. Got it. And that's most of the question, Vishal, right? In case if I missed some question, do put it in the YouTube video comment and we'll try to answer it. I will see like some have asked for the presentation and code. If it's possible, do share the link. I will add it to the video comment so anybody can
Sure.
try it out. I think that's about it. It was again like an excellent session, Vishal, right? And I echo the comments I have been getting. I didn't read out all the comments, but it was pretty much for me like I have not been able to catch up with Databricks for some time. I have a lot of videos on Databricks, but the new features, the new AI summit, and all this stuff that I've not been able to catch up. For me, also, it's a good refresher. Thank you very much, Vishal, for
Sure.
taking time on this Saturday and sharing your knowledge with us. It was really informative. Thank you, Vishal.
Thank you, Shivatsan, and everybody for listening and viewing.
Yeah,
Yeah, do let me know if any questions in the YouTube chat, and then I'll try to answer.
yeah. Thank you, Vishal.
Thank you. Bye.